Welcome everybody to another one of James's videos. Today we are starting a new section and it is exponents and surds for grade 11 and grade 12. Okay, so a lot of the laws are familiar from the previous grades. We obviously learn about exponents from grade 8 already, but there's a few extra ones that have been added in here and that are going to be a little bit more amplified in your questions going forward. And that would be the fifth law over here, which is changing a surd into a rational exponent. And then also your negative exponents, changing them into positive and vice versa. Okay, so guys, there's no getting away from it. You have to know these laws like the back of your hand, and especially these new ones, which are the surd laws, how surds work. Surds are roots, okay? So, excuse me, anything with a root, square root, cube root, fourth root, fifth root, anything that has a root in it is known as a surd. And then we'll go a little bit more in depth in those types of questions when we need to obviously simplify surds, and we'll tackle that in another video. But today we're just going to go run through the whole concept of exponents. We understand that when we are dealing with a term, okay, so if we're dealing with a term in algebra, it's made up of, let's say, for example, let's work this. So this is a term, okay? Now we need to understand that 3 is known as the coefficient. It's a little bit of theory, because obviously I'm going to say a lot of stuff here and I need you guys to know what I'm talking about when I do say these big words. So 3 would be the coefficient of this term. A would be the variable or the base, okay? So let's say variable. And then we've got 2, which is going to be the exponent. Okay. But together, it's known as a term, okay? But this over here is known as a power, okay? And what does a power consist of? A power consists of a base and an exponent. So actually, 3 has its own exponent of 1. Does everyone agree? So 3 to the power of 1 is actually its own power. So that is its own power. A is the base, 2 is the exponent. A power is something that consists of a base and an exponent. So when we're referring to the power or a power, it is a base and an exponent. 3a squared is a full term. 3 to the 1 is its own power. A squared is its own power. Okay, but then again, 3 is the coefficient of the power of a squared. Okay, just a little bit of understanding of how a term is actually broken up, because when I say the laws, for example, law 1, when timesing values of the same base, we add the exponents. Okay, same bases. So when we add powers, these are powers of the same bases, the a's, we add the exponents together. When dividing values of the same base or terms of the same base, we minus the exponents. When we raise a power to a further exponent, we times the exponents. And 3 has three different ways in which it can be represented. So when we raise many powers to a further exponent, every power in that bracket gets times by, the exponents get times together, okay? So 2 has a power of 1 here, so it would be r times 1, which is r, m times r, which is mr, and n times r, which is nr, okay? And then also we have the fraction version of this. So that is a power, that is a power. The only difference is that we're dividing them, but you would raise every power in this bracket to the power of r, and you would times those exponents together and get that fraction, okay? Anything to the power of 0 is 1, okay? A to the 0, 1. Anything to the power of 0, 1. An elephant to the power of 0 is 1, okay? That's how drastic we need to understand that anything to the power of 0 is 1. Okay, then we're getting to this over here, and now this is changing a surd into a rational exponent. A rational exponent is a fraction exponent, okay? Very important technique for this year, guys. Changing a surd into a rational exponent so that we can then work with the laws, adding or minusing or timesing exponents. Then changing negative exponents into positive exponents, and vice versa. What we do is we take it across the fraction line. So there's an invisible. A to the minus p is over 1, okay? It's a whole number, so it's over 1. And if I want to change it into a positive exponent, you just take the base that has the positive exponent and you move it across the fraction line. So in this case, a little example, 3a to the minus p. 3's exponent is 1, guys, so we don't need to change that into a positive exponent. But a's exponent, so the power of a to the minus p needs to be changed into a positive exponent. Hence why I'm only taking that underneath the fraction line and leaving the 3 at the top. 3 has a positive exponent. I don't need to move it across the fraction line to change it. But the a to the minus p, a has a minus p or a negative exponent, so I'm only going to take that power below. Okay, does everyone understand? Then we've got, we love 2s, 3s, and 5s. Prime numbers are obviously our friend when it comes to these, and so on and so forth. So what I'm going to do, let's shrink this, and let's put that over here, just so that we can remember it. And let's start with our first few examples. So example 1. Okay, let's have a look. Example 1 is the cube root of 9a squared times the square root of a to the power of 2/3 b to the minus 1 all over 3b to the power of 3/2 to the minus 1/3. Okay, looks scary, doesn't it? Quite daunting, this one. Lots of roots, lots of rational fractions, some negative exponents. So yeah, let's have a look. Lots of rational fractions, lots of rational exponents. Okay, cool. So let's get started with this question. So the first thing we do is we want to change everything to fraction exponents or rational exponents. So we're going to use law 5 here. Okay, so the cube root of 9. Okay, so that's going to be, remember, everything in this bracket. 9's got an exponent of 1. 3's got an exponent of 1. So if I'm going to use law 5, this is going to be 9 to the power of 1/3, a to the power of 2/3, times by, this is going to be a to the 2/3, and that you're dividing by 2, because there's an invisible 2 here, everybody. In front of a root sign, there's always an invisible 2. Like in front of a, there's always an invisible 1 as your coefficient. Same thing for the square root, there's an invisible 2 there. And then you've got b to the minus 1 over 2, all over 3 to the minus 1/3. Now I'm applying law 3b, if everyone wants to refer to it. 3b is what I'm applying for this bottom one. I'm timesing the exponent in, and that's going to be b to the 3/2 times minus 1/3. Okay, everyone happy with that? So this over here, from this to this, I've applied this law, law 5, just the root law. And then for over here, I'm also applying law 5. And then the bottom one, I'm applying law 3b. I'll mention the laws as we go along the question, okay? Now, we need to, let's first start by simplifying these fractions into just one fraction, okay? And then we can start looking for like bases. So 9, or let's change 9. We love prime numbers, don't we? So let's change 9 into 3 squared. Okay, there we've got a prime base of 3, and we've got a to the 2/3 times. Now, when you 2/3 divided by 2, you can use your calculator, but you can also test your mental math abilities. You flip the fraction, change it into a times, and you're going to be left with 1/3. And you've got b to the minus 1/2 all over 3 to the minus 1/3 b, and then it's 3/2 times, so that's going to be minus 1/2. Okay, now do you agree with me, guys, that everything at the top is timesing, everything at the bottom is timesing, and we're dividing? So this is one massive term. Do you agree? If I had to ask you how many terms are in this expression, you would say 1, because everything's timesing and dividing. Remember, timesing and dividing makes terms 1, plussing and minusing separates terms, okay? So what I can see already, just to make my life easier, I've got a b to the minus 1/2 here, and I have a b to the minus 1/2 here. I can cancel because it's one term over one term. Okay, there's no pluses or minuses. The next thing that I would look at doing is simplifying my bracket. So 3 squared. Now I'm applying law 3a. Anything, a power to the power of exponent, you times the exponents. So that's 3 to the 2 over 3, a to the 2 over 3 times, forgot about this times, come on, times a to the third, all over 3 to the minus a third. Okay, great. Now we can start looking for like terms, okay? So we've got a set of like terms here. So that's, when I say like terms, they have the same bases, which allows us to use our laws. And then we've got an A and an A. So for the threes, we are dividing. So when we divide values of the same base, guys, what do? We minus the exponents. And when we are timesing values of the same base, in the case of the A's, we add exponents. So what's going to happen here? This is going to give me 3 2/3 plus a third. A to the power of 2/3 plus a third is 3 over 3. So that's going to give me a 1. 2/3 plus a third is also 1. So 3 to the 1, A to the 1. So my final answer for this is going to be a beautiful simplified 3A. Okay, great. Hope you enjoyed that video, guys. If you did, we're going to be doing more examples. So please click the subscribe button below and look out for new videos. Also, all these notes are available in the James book. So if you are keen for a copy, please get in contact with us so that we can get you a copy. They are for sale. And yeah, look forward to seeing you in the other videos. Have a good one.